Now that you all are experts in how to do basic mole-to-mole calculations using a balanced chemical equation, now we're going to add in volume. Okay, so we're going to be dealing with gases here, and you should remember that there's a magic number for gases and volume that we've learned before whenever we're doing mole calculations. And so how many liters in a mole of gas? 22.4, right? For any old gas, it's always 22.4. So that's going to come into play here. Okay, so here's our example. It's the combustion of methane. Methane is CH4. And so let's say if I have 2.5 moles of methane, how many liters of carbon dioxide am I going to make? So notice this is different because I'm not asking how many moles of carbon dioxide am I going to make. There's a difference here. Okay, so because we're not dealing, mole to mole is one step, but here we've got a liter, which means we're going to add in now a second step. Okay, so let's start it off. My step one is what I learned before. Because I want to go from methane to carbon dioxide and I'm changing my compound, the only way I can change the compound I'm talking about is to use my mole ratio. Okay, so here we go. I've got my moles methane up here that was given to me in the problem. Okay, now I know I want to get to liters of carbon dioxide, but first I got to get to moles carbon dioxide. Okay, so I'm going to put moles carbon dioxide up here, because I can't go straight to liters. There's no special number for that, okay? And so then I'm going to look to my balanced chemical equation. There's an invisible 1 right here and an invisible 1 right here, so that's where that 1 and 1 come from, okay? And so now, if I do 2.5 times 1 divided by 1, oh gee, that gives me 2.5 moles of carbon dioxide. Now, obviously, that math was pretty easy, but usually you don't have a whole bunch of 1s. You could have some 3s, some 4s, some 5s, whatever. So that just shows you how to set it up. But again, the reason why we're using our balanced chemical equation here is because I need to get from methane to carbon dioxide. And the only way I can do that is doing a mole ratio and using my coefficients, okay? So I can't get to liters yet, but I'm going to in my next step. So now I know how many moles of carbon dioxide I have, which leads me to step 2. I'm going to convert those moles into a volume. So I start with what I know. This is what I figured out in my last problem. Notice that's not in my question that I'm given. This is what I figured out in my last step. I have 2.5 moles of carbon dioxide. Now finally I can put this liters of carbon dioxide. I can finally put that here because that's what I want to get to. And do we have a special number for moles to liters? We certainly do. It's 22.4, right? 1 mole is always 22.4 liters. And so here I'm going to do some multiplication, and then I would get 56 liters of carbon dioxide. Great. Okay. Let's look at another problem. Same chemical reaction, but I'm just asking you something slightly different. Okay. If I've got 18.2 liters of oxygen present, how many moles of methane are required? So if I want to burn 18.2 liters, how much of this stuff am I going to need? Okay. Notice here I've got liters and moles, so I cannot do this in one step because one step is just mole to mole. So whenever I have something else that isn't a mole, I know I'm going to need 2 steps. Okay. So let's set up my cross chart. What do I want to know? What do I know? I know I've got 18.2 liters of oxygen. Okay, I want to get to methane, but I can't get to methane yet because this isn't in moles. Remember, I can only change compounds when I'm doing a mole to mole ratio. So I got to get this liters oxygen to moles oxygen, okay? So it's basically kind of the reverse of the last problem we did. So I always know that there's 22.4 liters in 1 mole of oxygen, so I'm going to do some division here, and that's going to give me 0.81 moles of oxygen, okay? So now I've got my moles of oxygen, and thankfully that's going to be really helpful for step 2. I'm going to do my mole to mole. I'm going to use my balanced chemical formula. I've got 0.81 moles. Again, that was my answer from step 1. And now finally I can put over here my moles methane, which is what I wanted to get to in the first place. And whenever I'm going from like one compound to a different compound, I'm going to use my balanced chemical equation. I'll look up here, I'll see, I got 2 oxygens for every 1 methane. So that's 2 oxygen for 1 methane. So my math here would be 0.81 times 1 divided by 2, which is 0.41 moles of methane. Okay, so I'm going to need half as much methane as I do oxygen. Again, some of you might have been able to logic your way through that, but for a lot of these, the numbers won't be so pretty, and it might be something that you couldn't do in your head. But example 1 and example 2 are basically the same thing, but in reverse. 1, you start with a mole, you end with a liter. Example 2, we start with a liter, end with a mole. Either way, we're going to have a step that uses our 22.4 liters, and we're going to have a step that does moles to moles using the balanced chemical equation. Okay. Third example is, again, same reaction, but this time if I have 28 liters of carbon dioxide, how many liters of oxygen do I need to make that much? So notice I'm not moles in liters, now I'm liters in liters. Oof. If moles to moles is 1 step and liters to moles is 2 step, then guess what? Liters to liters is, ding, 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 3 steps. Get yourselves excited. So here we go. Let's set up our chart. We're going to start with our 28 liters of carbon dioxide because that's what it tells us. I'm going to need to get this to moles before I can do anything else. So that's what I'm going to do first. I have to get my liters of carbon dioxide to moles of carbon dioxide. And so what's my only liters number that I know? 22.4. Okay, so I'm going to do some division there, right? 28 times 1 divided by 22.4, and that gives me 1.25 moles of carbon dioxide. Great. Save that answer because we're going to use that in step 2. Step 2, we're going to go moles to moles. Here's where we're changing over from carbon dioxide to oxygen, okay? So I just figured out I've got 1.25 moles of carbon dioxide. I want to know how many, if I make that much of it, how much of the oxygen would I need? So let's see. If I look at my coefficients, for every 1 mole of carbon dioxide, I need 2 of oxygen. So there's my 1 and my 2. Great. So my math is going to be 1.25 times by 2. Divided by 1, which gives you 2.5 moles of oxygen. Great. Whew. Now I'm looking at my problem here. Am I there? It says how many liters of oxygen? Nope, I've got moles of oxygen, which means I need one more step. And here we go. Step 3, moles to liters. Okay, so now I've got 2.5 moles of oxygen. Finally, in my upper right-hand corner, I can put my liters of oxygen. Again, this is my answer from step 2. Okay, that's where I want to get to. And what's the only number I know about liters and moles? 22.4. For any 1 mole, there's 22.4 liters of oxygen. And so my math here is just going to be multiplying, right, and then dividing by 1, which you can just kind of ignore. So I'm going to get 56 liters of oxygen. There we go. Now I just showed you how to do this in 3 different steps, and the other problems how to do in 2 steps. There is a way to kind of set up like a double or triple cross charts to do it like all in one. And maybe I'll challenge you, if this made a whole lot of sense to you and you think it's super easy, try to figure out how you could do this all in one super duper cross chart. Otherwise, in class, I'll be stepping it through for you step by step. We will practice with this. But for those of you that this might feel a little bit easy, there is a way to not have all these individual steps. You can do it one long one. So see if you can figure it out. Write down any questions you might have, put circles around things, star them, and make sure to ask those questions in class.